Hello, everyone. All right, I'm here today to tell me how to DIY Ollie. This is actually a talk that I wrote a while ago, and while I was kind of revamping it for the conference, I realized that it uses a bunch of words that you may not be familiar with. So in order to make it a little bit easier, I'm going to give a better kind of working title here. I'm actually going to describe the terms as we go. But basically, it's how to collect observability data with the OpenTelemetry project. So I want to make sure I'm not using any TLAs or three-letter acronyms or these lovely abbreviations. I'm not sure what other term to use for TLA here, but the terms here are all going to be defined. I'm going to walk you through how it can really be made a lot easier using this project. So my name is Steve Flanders. I am a Senior Director of Engineering at a company called Splunk, which is in the monitoring observability space. I have over 10 years of experience in this space. My teams work on the OpenTelemetry project. I do doing this at Splunk, and prior to that at a stealth startup called Omnition that Splunk acquired about 3 years ago. Prior to that, I was at VMware working in the logging space. So I've done all the traces, metrics, logs type aspects for both open source, proprietary type solutions. So first, Ollie, as it's pronounced. The letter O, number one, letter Y. Why is it called Ollie? Well, it's because observability between the O and the Y, there are 11 characters. So it's basically an abbreviation of the name. This is very similar to Kubernetes, often called K8s. But just knowing what the term isn't really sufficient because the term observability is often overused. So I wanted to give a working definition for this presentation. And so the definition that I'm going to use is kind of the ability to ask unknown questions using telemetry data, so think things like traces, metrics, and logs, in order to solve availability and performance problems in your environment. Now, why do you need it? Well, the answer is kind of, it depends. Like if you're using a monolith, then maybe more traditional monitoring, and I'll describe the differences here in a minute, would be sufficient. But if you're dealing with distributed systems or microservices and you have a lot of complexity, just because you identify a problem, identifying the root cause or the user impact is actually a lot harder. And that's where observability can really help. Now, how do you get observability? Well, first you need to collect a whole bunch of data. And you might have heard of the 3 pillars of observability: traces, metrics, and logs. These are just data sources. Like this is the types of data that you need to collect. And then you need to be able to store this, query it, alert on it, visualize it in order to solve some of these problems. Start asking questions, basically, of the data. And that's what we're going to talk about today. Some people may know that I'm actually pursuing an executive MBA right now at MIT. I actually just flew here directly from class. And we were talking about something that was more management in topic, but it actually felt very relevant to kind of distinguish the difference between monitoring and observability. So this is a model where you basically have simple problems, complicated, complex, and chaotic problems. And what do you do in those circumstances in order to resolve an issue? And your approach is actually different depending on the type of problem that you're experiencing. For example, for simple problems, you often just need to categorize it and then you can go resolve it. Versus like chaotic things, you want to act. For example, if all of production is down and all of your customers are unhappy or you're losing a lot of money, it doesn't matter what the root cause is, you just want to get your services back online. You want to act and then you can go analyze later. So depending where you are kind of on the journey of problem space, your initial reaction is going to vary. This is also kind of true for monitoring and observability. I like to think of more simple or complicated problems as being a monitoring issue. Whereas for, let's see, we lost the display. I didn't do anything. No. Doesn't like me. We need to get some observability up in here. Let's unplug and try a different port and see if we get a better result. Sadness. I don't know. I didn't even touch it.
Turn it off and on again?
I did. Hey! I'll try to be gentle with it. We'll see how we go. So for simple or complicated issues in your environment, sadness. Literally didn't touch it. All right.
Is it just I need to stand here awkwardly?
Maybe. For simpler, complicated matters, typically monitoring can be sufficient. So this is more of your known knowns. I've seen this problem before. If I experience these symptoms, I have a run book or something that I can follow to go resolve that problem. Whereas for more of the unknown unknowns, you have to more probe and ask different questions and analyze and maybe even react and then figure out like what's happening. That's kind of where observability comes into play. So this is kind of a different mental model, so maybe it's helpful for you. I thought it might be kind of relevant to the topic today. Next, DIY, do it yourself. In this case, it's kind of similar to the build versus buy conversation that was being had in the earlier talks. What do you want to do with the observability information? Like, do you want to build your own solution to actually store it and process it, or do you want to buy a solution? And for each of those, I think there's a couple different dimensions. You have open source projects that you can kind of use off the shelf, or proprietary solutions that you can use. Which one do you choose? Well, I mean, open source, quick, free, kind of easy to get started. Sometimes it becomes more complicated because it's a black box that you may not know how to actually operate it or run it at scale, or maybe you need to hire a team to actually run it kind of long term. Vendors, they kind of offload two aspects. One would be the operation aspects. Sometimes they also offer enterprise features. Sadness. I'm not even doing anything. That's really, really sad. I'll continue talking and hope that it comes back. But the problem with vendors, of course, is the price aspect. So it's not free to use a vendor to run these tools and solutions. So that...
No, you're good. We might try to talk about that.
Yeah, I need to. Let's see if it comes back. I don't know. But the questions that you need to answer when you're deciding about how you want to do it yourself is like, where do you want to spend your time? What's the opportunity cost of doing something else? What's your budget for it? And don't say your budget is nothing. Like if your environment's down and you're losing a lot of money, you have a budget to solve some of these problems. But where do you want to invest it? Do you want to hire subject matter experts that run tooling for you inside? Do you want to offload to a vendor that you can then blame if things are not working properly? It's your choice at the end of the day, depending on your business requirements, but some decisions need to be made and you need to look over the entire environment when making those decisions. And then finally, we have OTel, which is the abbreviation for the word open telemetry. Now, some people might be wondering why it's not called like OT, given it's open telemetry. And the reason is because the precursor to open telemetry was two other projects, Open Tracing and Open Census. And Open Tracing was known as OT, so can't reuse the abbreviation here. So OTel is the abbreviation for open telemetry. This is an open source, vendor agnostic solution with the goal to provide basically instrumentation and data collection. So think of the things that you're deploying in your environment to generate, emit, and transmit all of the telemetry data that you care about. Now, OpenTelemetry does not actually provide a backend. Instead, it supports a variety of different open source and commercial proprietary backend solutions. And you choose through configuration where you want to send your data. We're going to talk a lot more about this today. You can see a rough reference architecture here on the right-hand side. So I want to drill into OpenTelemetry first, and then I want to kind of show you a demo of how you can actually get started with this yourself. OpenTelemetry has a bunch of different repositories, but there's basically three major components. The foundation to everything in OpenTelemetry is what's known as the specification. This is things where the API, the SDK, the data models, semantic conventions, and the like are all defined. This is meant to be an open standard that supports other open standards. So for example, it will be compatible with open metrics. It'll be compatible with different logging standards that are out there. The idea is it needs to be flexible so that you can plug into a variety of different backends if you want to. Quick question for the audience. How many people have heard of OpenTelemetry? Show of hands. How many people have used OpenTelemetry? How many people are running OpenTelemetry in production? Corey, take a look. There are people. So, now, beyond the specification, what you need is basically an implementation of that specification. That's what OpenTelemetry provides in terms of instrumentation libraries and a collector. So, instrumentation libraries is a language-specific way to generate, emit, and transmit, basically traces, metrics, and logs. And then the collector, think of it like an agent or an aggregator or a gateway service that exists in your environment that can collect, process, and transmit this data back out. You can choose which pieces you want to use. OpenTelemetry provides a reference architecture for all of it. Now, I can't drill into all the specifics in this talk, but I want to talk at a high level the value of, say, an open standard in terms of the OpenTelemetry specification. And I want to do that through some examples. So one of the biggest values that's provided here is data portability. What I mean by this is a couple things. One, there's something known as semantic conventions in OpenTelemetry. Think metadata, think key value pairs, think information attached to your telemetry data. Basically, semantic conventions help normalize what things are, objects, items in your environment. For example, let's say you're calling an HTTP endpoint or you're calling a database. If we can normalize what that looks like across all telemetry, we can do some pretty powerful things. Now, the examples I'm showing here, these are tracing or distributed tracing semantic conventions, and you can see some of the names that OpenTelemetry uses for these different types of objects. But let's say I have an application that I've instrumented with OpenTelemetry, and let's say I'm running in a cloud provider environment and I'm using a cloud provider's database, and my application talks to that database. Now, most monitoring or observability tools, clearly I can collect all of my own application data, but like AWS, GCP, they're not going to give me their telemetry data. They're not going to instrument their apps the same way I'm instrumenting mine. Maybe I can use their tools like CloudWatch or what have you, but I have to stitch that together. OpenTelemetry will allow you to basically do something like inferred services. I can see all of my application telemetry data and all of my calls to, say, the cloud provider database, and I can now visualize that, query over it, and ask questions about it in my observability backend because OpenTelemetry has these semantic conventions, which is very powerful. So as long as the destination of your telemetry data supports the OpenTelemetry standard, you can start to do some of these more powerful things like see in a service map a database that isn't instrumented by you. Now, you don't get full visibility because there may be other things calling that database, but at least for all the things that you control, you now have visibility into that data set. The other quick example I want to give that OpenTelemetry has made a primary concept is this notion of resources. So telemetry data from your applications is great, but where is that item running? Like which cloud provider, which Kubernetes cluster, which pod, what environment? This is called a resource in OpenTelemetry, and all the telemetry data is tacked on with resource information. This allows you to do problem isolation and to get to root cause a lot faster. For example, I might be experiencing an error and getting a lot of error messages coming in, but if I can quickly identify, like in this example, that there's a single pod that is experiencing all of those issues, I've now isolated the problem and I can focus in on that area instead of looking at my entire environment to try to figure out what is going on. As I mentioned before, instrumentation libraries, these are an implementation per language. The idea here is you can install a single thing into your application depending on your language, and you can get all of the telemetry data. You don't need a different instrumentation library for traces or metrics or logs. The goal is to provide a single solution for all. Now, OpenTelemetry prioritized tracing first. That's basically fully supported in all these languages today. Metrics has recently become GA, and many of or stable is the term that OpenTelemetry uses, and many of these languages have OpenTelemetry metric support, and then logging support has also been added. There's also talk of adding continuous profiling. In fact, a group recently got together to start defining like what that data model might look like in OpenTelemetry. But beyond your application, you probably also want to understand what is the impact to like users of your system. That's where something like RUM or real user monitoring comes into play, and OpenTelemetry has instrumentation libraries for mobile web browsers and mobile devices like Android and iOS. And then of course you have different packaging depending on how you run your workloads. Maybe you're in a serverless environment and so you need wrappers or layers or extensions, and OpenTelemetry provides this per language. So again, a single solution is the goal where you can get all the telemetry data that you care about. And then there's a collector. This collector is a single binary, and you can choose how you want to deploy it. So if you want to run it as like an agent, let's say I'm on Kubernetes and I want to run it as a daemon set on every single host, you can do that. If you want to run it as a standalone service and you want to have it aggregate information or maybe reduce the information that it's sending, you can do that. Sorry. And the collector is an extensible architecture. So the idea here is it's made up of a few different components. Receivers, how you get data into the collector. This can be push or pull based. For example, it's very common for traces to be sent from the application directly to like an agent or directly to a backend. Whereas metrics, maybe I'm using Prometheus and I'm kind of scraping an endpoint, that would be more of a pull-based mechanism. OpenTelemetry supports both models. Processors are what I want to do with the data after I've received it. Great examples here would be like CRUD metadata operations. CRUD, create, remove, update, delete type operations of the telemetry data that I have collected. And then exporters, just the opposite side of receivers, push or pull based ways of where I want to send that data at the end of the day. Now the collector allows you to, through YAML configuration, to define how you want all of this to happen. They call it a pipeline. And you can see a couple examples on the slide here, like the orange pipeline is receiving in one format and then exporting in a different format. So the collector can actually translate the data. This is why it can support a variety of different open source and commercial backends. Or the green one, where it's receiving in one format and exporting in two different formats. So let's say I want to try two different backends. Maybe I'm gonna do a bake-off, or I'm going to switch from one backend to another. You can do that with the collector as well. It's able to kind of handle those different types of use cases. The net result is a reference architecture like this. So let's say you're in a more of a greenfield environment and you want to add observability data and be able to collect this. You could go all in OpenTelemetry, you could add it to your application, you can add the collector and you can send it to the backends of your choice, but that's not a requirement. You can pick whatever pieces you want. Let's say you're using Prometheus metric library today. Continue using it, the collector is able to get that data. Let's say you already have your own agent, but you want to add distributed tracing. You could use the OpenTelemetry library to do that and not have to change your agent infrastructure. So again, flexibility and choice is part of the game here because the OpenTelemetry project understands that every environment's different, every use case is different, and we don't want to have a high amount of friction in order to get started. Maybe it's me touching the table. I don't know. We're going to see. Try again. Please come back. All right, cool. So now we talked a lot about OpenTelemetry. This is basically your side of the environment, like what you are doing to instrument and emit this data. And then you have kind of the back end. From a DIY perspective, it's been very common that both of these are treated as a single unit. Let's say I'm going to use, I don't know, let's use Prometheus as an example. I want Prometheus to be my back end for my metrics. I'm probably going to use the Prometheus client libraries. So it's kind of like a package deal. And this is true for vendor solutions as well. Usually vendors will provide their own instrumentation or agent aspects. OpenTelemetry is trying to break the mode here, saying that you don't have to treat them as the same. And the reason why this is important is because instrumenting and deploying like agents and collectors in environments is a non-trivial amount of work. We saw examples earlier today of actually trying to instrument your app. That takes time. You need people that make the code changes. You need to test that, make sure it's performant. You need to roll it out to production. That's a non-trivial investment. What if you could instrument and collect data once and then move to a configuration model where through configuration changes only, you're able to decide where that data goes, how much data you're sending, when you stop sending that data. It makes it a lot easier for at least your side. Now, you still need to go support like whatever's necessary to persist, query, alert, visualize, and the like. So if you're going to run your own backend, you still need to manage that, but you could also use a vendor for that if you wanted to as well. Again, providing you kind of choice there. So with that, I want to give a demo. And actually, when I put this talk together, this demo environment didn't exist. But luckily, some people in the OpenTelemetry community recently established this new repository called the OpenTelemetry Demo Web Store. And I'm hoping that I'm going to be able to show my terminal, but this display is being a little interesting. So we'll see how it goes. But basically, this is a microservices polyglot, meaning multiple different programming languages environment that is going to be instrumented with OpenTelemetry. And I'm going to be sending data to a variety of open source projects, Prometheus, Jaeger, Elasticsearch, and the like. So let's try this, and I'll try to go very, very slow. So first, I'm already running this. It's actually a Docker Compose file. I'm just trying to prove this is real. I'm going to do this live. We'll see how it goes. And here is the online web store. So it's an online boutique where you can basically purchase items. And this is a microservices backend, which I'll show you in a minute. So I can click on, I don't know, the sunglasses here. I can add it to my cart. I can navigate to other aspects and choose different items like discount coupons. And this is no different than you interacting online with any sort of website. Now, when I do that, what will end up happening is I will start generating traces. So here's an example of basically the operations that I'm just performing from a back-end perspective. And as you can see, it's complicated, right? The front end has to talk to the product catalog and then the currency and the cart service, the recommendation service, like a lot of interactions are happening. And this is all captured for me automatically in terms of spans, which are then represented as a single transaction or a trace. So if you're familiar with distributed tracing, this is an example of it. And then in here, I have a bunch of metadata. So for example, I mentioned some of the semantic conventions. Here's OpenTelemetry defining HTTP calls. I can see the host and the method and the route. Useful pieces of information in order to ask questions should I have a problem in my environment. Beyond this, I have rich infrastructure information. So in my case, I happen to be running this locally on my laptop, so it's less exciting, but it's on Linux, and here's the host name of my system. But let's say I'm running in a cloud provider or Kubernetes, I would start seeing pod information, region information, anything about the environment that would be kind of useful, and then I can slice and dice my data in order to ask questions about what is happening. I can also add information in different aspects. Like in my application, I can add metadata. From a collector perspective, I can add metadata. For example, I'll show you that I've actually added this Monitorama key value pair directly from the collector. So all data kind of coming in, I'm enriching with additional insights and information. Now, this is all being done through the instrumentation libraries I talked about. There's actually two forms. There's automatic instrumentation and manual. Manual means you go make code level changes to your application. That's a little bit harder because again, I need to actually go edit my code. Automatic means I basically change runtime parameters and I start my app up and I get instrumentation automatically. So bytecode manipulation is another term for this. Automatic's a lot easier. Changing runtime parameters and restarting an app, not nearly as challenging as actually making code level changes. I'll show you both in just a second. Then from a Prometheus perspective, I actually have a collector up. It's scraping a couple endpoints here. I can kind of show you that this data is real. So for example, I can see OpenTelemetry collector telemetry data coming in. I can check the metrics of this. I also have HTTP endpoints for my application that are coming in. So basically, the collector can either push information out, so you can do like a remote write type operation, or the collector can also serve as an endpoint that Prometheus can scrape in order to get the metrics to the Prometheus server itself. I also have an Elastic instance up. I'm using Kibana, and I have log entries coming in here, and you'll be able to see when I show you kind of the demo environment that this is one of the services. It's called the ad service. And again, even the telemetry data I showed you for like the Monitorama tag, it's actually showing up in the logging platform as well. So I can ensure kind of consistency regardless of the tool that I'm using. Okay, with this kind of background, I'm going to try very carefully here to show you demos live of how all of this works. So here we go. This is a microservices app. So every folder here represents a different service, and these services are written in different languages. So for example, if I go to the ad service, this is a Java application. In this Java application, if I go look at the actual code for the app that I'm running, the ad service app here, what we're going to see is traditional like Java code, and it's verbose like Java is. But if I search for OpenTelemetry, you're going to notice that OpenTelemetry does not exist in here. So this is just some software developer put together some code. There's no actual instrumentation in this app whatsoever. It's just an application. But it is currently emitting spans that I can see in Jaeger. I can show that again in just a second. And the question becomes, well, how did that happen? And how that happens is there's this jar file. It's a Java agent. This is specific to Java. But if I add this jar as a runtime parameter to my application, it will automatically instrument it and automatically have it start emitting spans, metrics, and other useful information. Well, how do I change my runtime parameters? I have this, I'm using Gradle, so I have a build Gradle file, and right here I'm just saying pass the Java agent flag and use the jar file. So pass in the jar, start my Java application. That's pretty much it. The only other thing would be if I care about environmental variables that configure more information about the ad service, and that I can also specify here in my Docker Compose. So I'm saying like,
I want to set a service name. I want to call this the add service. Maybe I don't want to send this to the collector. I want to send it directly to a backend. I could specify an endpoint that I want the destination for that data to exist. That's it. Start the Java application up. I now have telemetry data. Extremely powerful. So it doesn't have to be hard to get started with distributed tracing. Now, if you want to manually instrument it, there are, of course, more steps. And what I'm showing you is a Java-specific example. It varies a bit depending on the language that you are using. So next, let's take a quick look at the currency service. This is a JavaScript application. What does that process look like? Well, here I created a simple tracing.javascript file, a single file, with basically some boilerplate code for OpenTelemetry, specifying like the dependencies that I want to have and that I wanted to use auto instrumentation. And then I start my JavaScript file here with the tracing.js file. That's it. Again, pretty easy to get distributed tracing and metric information out of my JavaScript application. I'm not really changing the code. I'm basically adding a dependency and I'm adding a runtime parameter. Let's give one final example. We'll go to the email service. This is a Ruby application. And the reason why I want to show this is because it doesn't have to be an either or, like an automatic or a manual. It can also be a both. So for example here, if you're familiar with kind of Ruby code, we have our requiring dependencies. This is similar to kind of the JavaScript or Python or anything else. Then you call in your auto instrumentation libraries. So this is using Sinatra. And then if you want to, you can actually enrich it. So let's say I want to set my own metadata. Here's me adding a bunch of key value pairs specifically in my code. So if I want to enrich what's actually being emitted with the auto instrumentation, I can do that. Let's say I have my own function, like sending email. I can generate my own spans manually. Yes, you have to add it manually if it's not auto-instrumented, but a few lines of code, I have a tracer, I have spans, it's pretty easy. This is kind of similar to adding metrics or custom metrics into your application. You're going to need a few lines of code. It's no different with OpenTelemetry. The idea is you can do this regardless of the signal that you care about. Okay, so then finally what I want to show you is the OpenTelemetry collector config. So as I mentioned, it has receivers. You can kind of see them at the top. I'm using a small subset, but there are tons available. There are processors. So for example, how I'm able to add my operating system information is through this resource detection processor. These exist for cloud providers as well, OpenShift and other environments, Kubernetes and the like. So you can actually enrich all of the telemetry data that's being emitted. You can add your own metadata information. So for example, that deployment.environment that I showed you with the Monitorama value, that's me adding that as a YAML configuration file into the collector, and now all telemetry data that's being processed will have all this information. And then finally, I can define a variety of different pipelines. So for example, for traces, I'm receiving them in OTel, which is OpenTelemetry's protocol. That's what the instrumentation libraries support by default. And then I'm exporting it in Jaeger format to a Jaeger endpoint. That's how you saw the Jaeger UI. Same for metrics being Prometheus, same for logs being Elasticsearch. I can add as many pipelines as I want. I can change the configuration. All of it's pretty straightforward.
All right, so wrapping up, I have a bunch of resources if you're interested in like trying this stuff out. Many of these projects are CNCF or Cloud Native Compute Foundation projects, which means they are vendor agnostic. Some of these are just open source projects, so there may be a vendor behind them, but they're open source and kind of free to use. But feel free to try out any of these. It's kind of plug and play with OpenTelemetry. And with that, that wraps it up. Thank you so much for attending.